Okay, we are on the hour. So here we are at another OpenChain webinar. Today's webinar is a little bit special for a couple of reasons. The first one is that we are going to be covering two topics. One is a case study around ISO 5230, the international standard for open source license compliance. And that's going to be in the context of a company. The second part of this webinar is going to be talking about research around ISO 18974, the international standard for open source security assurance. It's unusual for us to cover two topics like this, but we do have a rather unique reason, which brings me to overall the other very exciting part of this webinar. Our presenter today, Charlotte, is someone who has worked in the industry as part of a placement, but has also been doing research at university. So this is the first time we're going to have a recent graduate present to us about research and practical business matters. This is motivated by a couple of different things. One is to cover the area of academic research. That's something that we have only looked at in, I think, 2 out of our 90 plus webinars. The other is to hear the voice of rising next generation. It's time to give the floor to people who are looking at open source and open source business and open source standard with a fresh eye. Before we start, as always, I'm showing the antitrust policy notice. The full antitrust policy can be found on the Linux Foundation website. If you're from a Linux Foundation member company, you can ask questions of our council and the Updegrove. The purpose is to ensure that everyone feels comfortable sharing, talking, and collaborating. Now, without further ado then, and to ensure that my background noise is reduced, I will stop here and hand over to Charlotte for her presentation. As always, this is an OpenChain webinar, so you should feel free to jump in with questions if you have any, and we will have some space at the end of this call to collect questions if you want to wait until the end. Charlotte, thank you for coming here today. I'll stop my share, hand over to you, and look forward to your topics.
Brilliant. Thank you. Thank you so much. Right. So I will share my screen. Can you see that? Just double checking.
Yeah, we can see it fine, Charlotte. Yeah.
Okay, thank you. So I thought I'd start with, an introduction to me. So I'm a recent computer science graduate from the University of York. I hadn't done computer science before starting university, so it was definitely a big learning curve. And I was very much thrown into it and learning lots of different concepts. So I first joined endjin for my internship in 2021, and we were set with a project to generate synthetic data that could, represent the normal population. It was a really great sort of data project to get thrown into, my first real application of programming and seeing what you can actually do with it. And then that led me to come back for my year in industry with endjin a year later as part of my university degree. And that was a year-long project where I worked on OpenChain, ISO 5230, so license compliance. And that was brilliant project. And it sort of looked at all the different aspects to start right from the beginning of the project, from sort of discovering what it is to actually implementing it and seeing the results firsthand. Which then led me on to my final year dissertation when I reached my final year of university. And they allowed me to work with Engine in industry and work on the second strain of OpenChain, the security assurance side. So there was a lot of sort of research about what that meant and best ways to approach this problem in context to Engine, which I will all cover upcoming. And yeah, and then also a bit of background. I've just moved to Cambridge and I'm starting at Darktrace in September. I'll be joining the research and development team for software as a service security. So I'm really excited to get into that and yeah, start applying my knowledge. So also a little background about Engine. They're a boutique data consultancy with like, special expertise in Azure, data analytics, and specifically .NET as well. And I've already mentioned this, but yeah, I joined in 2021 and then returned in 2022. Um, and they maintain over 60 open source projects, which is pretty key for this talk. So yeah, starting off with the license compliance one. So initially, when I started this project, I didn't even know what open source software was. So it was definitely a learning curve of sort of understanding what is OpenChain, why is this a standard, and sort of to get to that, I had to learn about everything that comes around it. So having not really used open source software before, written it, or had much experience with it, it was getting to understand why these this compliance is important and why, yeah, why is this standard important? Why for Engine is it important for them? So I took a couple of courses to get a sort of good background knowledge of the subject. So I took source code controls, getting it right with open source software course. Thank you to Martin and Holly for giving me access to that. And that was a really good sort of overall background understanding of yeah, open source software and licensing and stuff. And then I also took the Introduction to Open Source License Compliance Management by the Linux Foundation, which is also very good as well. And this allowed me to gain sort of an overall understanding of open source software, licensing, compliance, and best practices. So starting out and sort of just understanding what this was all about. So then the next step was to understand Engin's architecture. So it's going to be different from company to company. No company is going to be the same in the way that they implement these processes because Engine have a very specific architecture. So it was the next step was to look at that and decide what would be best um, for them. So in the end, we sort of decided GitHub and using GitHub Actions, Azure, and then integrating into CI/CD processes. So you'll see more about this in a second. But those were the sort of the main points that we wanted to integrate this in with. Definitely CI/CD processes, which I will get to in a little bit. So this is Engine's OpenChain operating model, and thank you, James Dawson, for creating this for me. So it sort of outlines the different sort of processes that are designed for throughout this project. So you can sort of see the vulnerability analysis in here as well, which I will talk about further on, but you can sort of see the which parts are in certain boxes. So CI/CD, that's where we generate the SBOMs and look at the license compliance and the vulnerability analysis. And then at the end here, these are our sort of outputs, like what we're going to do with this information, which I'll look into this a bit later. So talking about our SBOMs, because they're a pretty important part of compliance because they represent your system as a whole. So it was very important for us to get these, obviously, because you can, yeah, see all the licenses that you're using for each component. But Engine generate their SBOMs with Covenant, which is by Patrick Svensson, and it's beneficial for them because it supports .NET and NPM, and they can also add a custom format with additional metadata at the top. So it will also have the GitHub organization, repo name, Git branch, and then Git commit. Um, and these were this is like a custom format of SPDX SBOMs. So these were generated as part of Engine's DevOps practices, so the CI/CD processes. And every night they will be generated again and stored into the cloud. So, um, yeah, so that's sort of SBOMs, I guess. So after these SBOMs are generated, there's two different ways that we use them. So it's sort of to make this a fully automated process and to ensure that um, licenses that aren't meant to be used are caught in time or discovered. Um, we're looking into thinking, okay, so if someone makes a change to the code and they add a component that has a license or a dependency that has a license that we don't want to use, we want that to be caught before it's actually merged into the main code and the changes are actually made to the software. So this is the sort of the CI/CD section part of it. And it's part of the GitHub Actions process. So whenever there's a change, PR that's created, um, an SBOM will be generated and will be checked. And then it can block the PRs if there are changes that would result in a rejected license being used. So it's a bit of like yeah, it sort of tries to catch them before they actually become a problem. And then there's also another strain where it's the bulk run. So you can get all of the SBOMs for every single software system and analyze them all at the same time. So because this is quite a lot of data processing, data analysis, this is all done in Azure, which can make use of the parallelization in Azure Synapse. Um, so you can have then an overall view of the system. You can, yeah, gain an overall understanding of the licenses being used and what are not being used. And yeah, so it's more of an overall view, whereas the first one is specific to each repository. And for this, I wrote this sort of general script called SBOM Analyzer, and it can be used in both the CI/CD and the bulk run processes. So it's designed to be used both in pure Python and PySpark, so you can still make use of the parallelization. Um, yeah. So a bit more about the SBOM analyzer. So it's designed to extract the information from each SBOM and then produce meaningful results from it. So um, it will take out the licenses and copyright notices alongside the components and then check it against business logic. So I will talk a bit more about the business logic in a second, but um, after that, scores are generated, which are basically just a representation of how many accepted licenses there are, how many licenses are there that were not accepted, and then there's sort of another column for unknown, because there were some that didn't have a license registered or the copyright notice wasn't very clear. So um, sort of in terms of the business logic, there were lots of discussions around what makes a license accepted or rejected. So which licenses are Engine happy to use and which ones would they like to avoid? So this was quite a key part, I guess, of the process because we're really deciding what is going to be okay and what is not going to be okay. So some examples of the accepted licenses that we have been allowing might have changed since I left is MIT and Apache 2.0 because they're generally permissive licenses and ones that should be fine to use. and some rejected licenses. I know like the GPL license because they're probably more strong copyleft licenses. So any licenses that aren't recognized or have a copyright notice would be flagged as unknown, which would require someone to manually check what's going on. And there was also some sort of special cases because obviously Engine, they produce their own open source software and they use it as well. So some of their licenses are ones that they generally wouldn't accept from a different company or a different developer, but from themselves it's all right for them to use. So there's sort of an additional check to check for the SBOMs that they were coming from, the repository names, to check if it was made by them or not. And if it was, then they could still use that license, even though generally it's not one that they would accept. So there was certain special cases like these that we needed to consider because we didn't want it to just flag up everything that Engine have developed and then end up with lots of problems further down the line. So these scores are sort of produced after the SBOM analyzer has been applied to the repositories or just the singular repository. Um, and after this, the rejected licenses can be reviewed and removed from the system. Um, at the beginning, there could be quite a lot to remove, but as more get caught in the CI/CD processes before they're merged into the code, it will become more autonomous and there won't be as many that will need to be removed in the bulk review. And then the scores include the number of accepted, rejected, or unknown licenses. So sort of now we're at the final stage of the process of using this information. So we've generated all of these SBOMs and we've analyzed the information within them, but now what are we going to do to actually make sure that this information is used in an appropriate way and a way that will be beneficial for Engine and a way that they will actually catch these errors? Um, so I think at the moment there are currently two places where they're being used. In Slack and Backstage, which I will talk more about. Yeah, so as you can see, it's just in this last section here. So for Slack, there's a daily message that gets generated, which is produced after the SBOM analyzer is run. I think it's just a simple script that can connect in, and it will give a summary depending on the amount of licenses that are rejected or accepted. So you can see here that there's some ticks, which is great because there's no rejected components. However, in the chance that there are rejected components, it's very obviously different. So if someone were to check it and it was red, then they would know that there's something wrong and there's something to check. So we made sure to design this very clear so that you know if it's going right or wrong. You don't have to specifically look at the individual numbers to work it out. Um, and this is just one way that you could be alerted. This may be sort of the first port of call. And then if you see this and there's errors, then you might want to go on to Backstage, which is Spotify's open source framework for building developer portals. So you can sort of build your own sort of development site and it has all the information that you need on it. So this site, we design it to access the scores from the Azure Data Lake, where sort of after they're bulk run and generated, they get stored. So it's always easily updated and ready to go, and it displays the information, so it's easy to see the results. So that you sort of have, if you look at this particular repository here, you can see how many are accepted licenses there are, any unknown and any rejected. And then below it will actually list the specific information for if there are rejected ones or the unknown ones. So you can see here it hasn't registered a license or a copyright notice for this component. So that will be listed as unknown. And then there's sort of another tab, which is just an overall view of all of the repositories. So you can have a general guide as to what's happening across the whole system. Yeah, and then Engine also have developed a framework called the IP maturity matrix, and it measures engineering practices quality of a repository. So, for example, how much is documented or how much code is covered by testing. So we decided to add our SBOM score, um, meaning it can increase the confidence in the code, knowing that repository is being checked. So in this instance here, we designed it so that 100% means that the repository is generating an SBOM and is being checked, and then 0% means that an SBOM isn't being generated. I think we're also going to add another one as well that could sort of show what percentage of the licenses were all right or not. But I'm not sure if we ever got around to that. But yeah, it's also great because you can see this on each individual repository. So this is just a screenshot from GitHub, and you can see sort of the state of the repository. So sort of from Engine's perspective, why is all of this beneficial? So they maintain over 60 open source repositories, so having an up-to-date view of the software supply chain has been reassuring. You know exactly what's in it, and exactly what you're using. Um, so implementing these processes, it doesn't have to be big or scary. Like, I mean, I started and I knew nothing about open source software, but it's just important to figure out what the requirements for the company are, and then you can understand what's important from that. So Engine use DevOps practices everywhere. So for them, it's important to integrate it into those low-level processes. So it runs by default, and people don't need to worry about um, sort of I'll have to make sure this license, or I have to manually check this before merging. It will all be automated and people won't need to worry about checking things. So yeah, in DevOps terms, the bit of quality. So it's set up just to happen rather than needing to be switched on. So then it's also important to start small and iteratively build on what you have from feedback that you start to get. So I think at first we just started generating the SBOMs and saw what sort of information we got and decided how that could be useful and what information we'd actually want to extract from that. And yeah, it's important as a consultancy because now they can see the supply chain considerations forming part of commercial terms. So it's positive to see these effects feeding back into these sorts of conversations. Um, so yeah, that's sort of just from Engine's perspective why this is good and um, yeah, the sort of overall benefits of it. Um, so I just thought now I'll move on to the sort of the second strand of it, which was focusing on, well, my dissertation. So I returned back to uni after my year in industry, and I started my final year project. So this one I was looking at the sort of the newest strain of OpenChain, the security assurance one. Um, it's a year-long project and contributes to a third of my final year grade. Um, I was supported by both my supervisor, Konstantinos Barmpis, and Engine. So I had lots of input and lots of support throughout this process. And my dissertation, I came in with the focus of threading together the processes that Engine can easily use in their existing system. So the aim was to simply just track the components that Engine are using and detect any vulnerabilities. Now, it doesn't seem like a lot of work at the moment, I guess, because they're already tracking their components. So the next step is just to detect any vulnerabilities. Um, and due to the nature of the project, because it had to be self-contained, I couldn't cover all the components of the specification. But I focused mainly on vulnerability detection. So I wanted to just put that out there. Just there's parts that haven't quite been fulfilled yet, but yeah, due to the nature of the project. So that leads me on to this diagram, which is quite bright. But it's a representation of how my system was formed and how it works. So sort of starting the process here with the input data. So from the data lake storage, the SBOMs will be fetched, and these will need to be flattened and then cleansed, because something I came across was that, well, actually, I'll talk about the vulnerability scanner first, actually, because as part of my dissertation, I wanted to create this myself. I thought it'd be a really cool project to go off and extract data from these vulnerability databases and compare it against components. However, there are so many tools out there that already do this, and my supervisor said, no, absolutely, that would be a waste of time. Don't recreate something that already exists. And I mean, yeah, it makes sense. It would have been a cool project, but it makes sense. So I did quite a bit of research on all of the different tools out there. I'm sure some of you know there's quite a lot of ones you have to pay for, but then there's also some open source ones out there that are free to use. And I'll discuss which one I chose a bit later on and why. But these vulnerability scanners need a sort of specific format of SBOM, which, as I discussed earlier, Engine have a custom format. So luckily, Covenant, the tool that they use, has like a built-in converter that you could just easily convert them to as like a general format. So I think I did SPDX for um, this project. So yeah, so I flattened the data and then cleansed it. That's part of the cleansing, is transforming them from their custom format and then becoming the SPDX, and then they can be scanned, and then vulnerability reports are generated. And then we sort of get into analyzing the vulnerability data. So um, this is where the information is extracted and then reports are generated. So we get a summary report and then a refined vulnerability report as well. Um, I will show you this later on. I've got some screenshots as to what each of these are. And then the results get published to the data lake. Sort of, it would be in the same place that engines store the other strain of OpenChain's results as well. So, well, for my actual implementation, it wasn't, because mine was self-contained, but I designed it in a way that it would be easy to, lift up and then drop into engine system. And then this information would therefore then be added to the Backstage site as well. Um, I was going to add a screenshot of this, but I couldn't find one. But yeah, I will find one. So the vulnerability detector I chose was Trivy. It can scan repositories, container images, Kubernetes, and virtual machine images. However, we already had SBOMs, and Engine were already using SBOMs, so it made sense just to give it an SBOM. And um, it consumes security advisories from multiple different data sources. So, which is key. It's what I was looking for as part of my research. I determined that, you can't just have one source, you have to have multiple sources. I looked more into depth about CVEs and all of the different processes that come along with vulnerabilities. Um, Now, the first tool that I chose for this process, I think called Bomber. Um, it was a good tool, however, it didn't give the version fix. So it identified the vulnerabilities, but it didn't tell you which versions, um, well, the next version that would fix this issue was, which is a pretty key point of this um, specification, is to make sure that you are actually making these changes. And because we were designing this system to be almost fully autonomous, we want these fixed versions to be generated. So after some more research, I came across Trivy, and that's what we're using at the moment. And it's also a lot quicker. I think it pulls all the information first and then compares the components rather than having to continuously fetch information, which makes it a lot quicker. Um, so more onto the implementation side, I think I've already talked about quite a lot of this already, actually. Um, so I think this is my GitHub Actions workflow. So this is sort of I strung all these processes together that demonstrated getting the S-bombs and um, cleansing them, scanning them, producing these results all through a GitHub Actions workflow. So this is sort of a diagram explaining sort of the different steps along that, and how the information feeds from one part to another. Um, and then there are also quite a few functional and non-functional requirements for this project, which is something that's very key in software engineering is, defining these requirements, especially because I treated Engine in this instance as if they were like a customer or someone I was creating a software for. So you need to understand what do they want and um what are they looking for. If I just produce this in a way that I thought was cool, that's not exactly what they want. So it's really important to have these functional and non-functional requirements. And I actually found that over the sort of the stretch of the project, these changed dramatically as I discovered new things and as I did more research. And um, in the end, I came out with a sort of a sort of robust list, but there were even more even after I finished that I discovered and ran out of time to do. But yeah, it's an ever-changing list of requirements. I took three just as an example to show you. So generate a report with patch number recommendations and then whether I fulfilled it or not. So I think I did manage to fill most of the requirements of this project, which is very good. And these are just some screenshots from my GitHub Actions workflow that I was just talking about. So it sort of shows each step of the process. So you got the vulnerability scanner, and then you analyze the data and you publish results to the data lake. And I wanted to have these sort of separate from one another because they use very different tools. So it's easier for debugging and um, overall easier to understand and track. And then the results are sort of outputted here as an asset. Um, so as a release which contains assets. So um, I release them both in CSV and JSON format, depending, so they can be used in different ways. But I will show you. So this is the vulnerability report, just not refined or filtered at all. You can see there's a ton of information on here. A lot of it probably not that useful when you really want to know what's the vulnerability, what's the severity of this, and how can we fix it. A lot of this isn't going to be useful. So then, I'll come back to that one actually. So then I sort of had this summary report. Well, I think this is like a refined vulnerability report. Maybe I've got the wrong name there, but um, it has a lot simpler information. So it's just got the name of the S-bomb, the severity of the vulnerability, um, the installed version, and then which version it needs to be fixed. The name of the component that has this vulnerability, and then how much of a change is it going to be to update? So this was quite a big thing, is to sort of automating. If it's a patch, it's fine, update it. But if it's a major change like this one, then that's going to need some sort of manual intervention to check that it works with the current system. It won't break anything. But patches should be fine, for example. So this is all sort of logic that can be used later on when engine implement this into their own processes. And then for sort of ease of checking things, I also separated the org name and the repo name out from one another. Going back, there's this one as well, which is just a very simple, um, summarized version of the report. And this can be used for the Backstage site. and for Slack messages as well. So it contains hardly any information, but it gives an overall view of the system as a whole, so it's very easy to sort of understand what's going on. Um, so then, um, yeah, I thought I'd pop this back on just to sort of show you the different things that I just talked about and how um, these are the reports that I've just shown, and then these will get added to the data lake and then subsequently into the Backstage site. And then, yeah, I've just got some relevant links that might be useful if you wanted to go have a look more in detail at anything else. Um, but yeah, that's it from me. Um, any questions?
Thank you very much indeed, Charlotte. Before questions might come in, just an observation that that was a really great case study. It was really interesting to hear how Engine implemented these things. And I think it might be the most detail we've gone into on the practical how-to, which is both impressive in terms of Engine and your work, of course, but also impressive in the information it will provide people as part of our reference library here in the webinars. So thank you very much.
Thank you.
Now, the floor is open. Questions? And I'll get it started with one. Your research continuing into ISO 18974 seems like a natural continuity. And it's, of course, very useful for us to have that adjacent to your original work. My question is that, did you find the commonalities between the standards meant that the research into how they work, how they could be implemented, indicated that if someone uses one, it's relatively easy to use the other, which was an assumption we had, but it's a question to you to see how that played out based on your experience.
Yeah, absolutely. I think so. Sort of like I spoke about earlier, like Engine were already generating S-bombs and they were already sort of it was a very similar process. As in there wasn't a lot to do around the setup of all of it. It was very much, okay, this is just an extra piece of information that we want to use and more insight that we want to gain from the S-bombs. And I think actually the language of the specification as well for the security assurance one was very similar to the license compliance one. So it was easy to understand that the motivation was the same and the sort of the 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 reason for doing it was the same, but it's just slightly different information that you want to, yeah, gain insight into.
Now we have a question in from Steve, and it sounds like you're using SBOM as the canonical representation of the information. And as the medium of exchange in different parts of the system, rather than, for example, ingesting the SBOM contents into a local database. So is that correct? So is SBOM the source of truth here as opposed to a local database? And he has a follow-up about choosing Slack and Backstage. Is that because they're already deployed in the organization?
Yeah, so the SBOM is the representation of the system. So within um a certain time frame, I think a new one's generated every night. And that information is sort of after all of these SBOMs are generated, which each represent the sort of current state of the repository. Um, in the cloud, they are processed and then sort of saved as a database in a way so that you can see every single repository against the information that's generated from it. Um, and yeah, this is all in the cloud. So yeah, everything's sort of updated and saved. I think we also save the history of the S-bombs as well. So if there's anything we want to go back and check, we're able to do that. I hope that sort of answered your question. that respect. And then sort of choosing Slack and Backstage. Yeah, absolutely. So Engine heavily use Slack sort of for communication. So it was very much the obvious choice. Because everyone looks at Slack regularly. So yeah, definitely that was one that was already used and Backstage as well. Yeah, I think I'm not sure how regularly, but Engine, yeah, definitely were already using it. So it was, I guess that's the point is it's very important to use sort of technologies that you do already use, um, because you're more likely to use them in the future, going on, and you're more likely to see the content, and you know it works as well.
That's actually a really good point. One thing that has come up many times over the years is the question of to what extent do I need to introduce new infrastructure or change infrastructure? And the answer is a recommendation as little as possible. If things can fit into existing processes, that's fantastic. And to start with that mental model seems sensible. So it's really heartening to hear that that was the case as well. Right. We have a comment in from Howard, just in reply to Steve as well. Howard was just saying we have code ops processes. So the processes for managing DevOps, it's a little bit meta. So given the code ops processes, we wanted something that could integrate into this so we could scale it out across our IP estate. The SBOM gives us a dependency graph of all components. The reason we needed a custom format is because we wanted to capture more information than the specification supported. So like code branch names and so on. The reason we used an Azure Synapses Data Lake were that these were skills Charlotte developed in her internship. The work we've done subsequently is to containerize all of this logic so you can run it inside a GitHub action and decide where you want the SBOM data or files to be written. So Howard's note there explains some detail and also flags, I think, an interesting fact that the work in Engine has continued to refine on this. Regarding Slack and Backstage, also building on Charlotte's comment, Howard notes, echoes that Engine wanted to integrate into existing processes that the team already uses to reduce friction for adopting. So that's really good. Right. We've had a very productive presentation here, and there's, I think, time for one more question. Oh, an earthquake is about to hit me. Sorry for that noise. That's interesting. In apparently, uh, yeah, now. Okay. While the earthquake is hitting, there's time for one more question if people have it. And I did notice a comment from Howard. We do want to open source the work that's been done so others can benefit. But there's a few more things to do to decouple it. Howard, that's really good news. And it's something we've seen in the past. For instance, LG Electronics open source their internal compliance tooling. It's called Fosslight, but it took them a considerable time to get that ready. Right. Any last question?
May I?
Yeah. I'm going to be hit by the earthquake in 9.3 seconds, so I'll go on mute.
Good luck. This could be a bit larger question, but like I don't know, Charlotte, if you can talk a little bit more like the compliance, let's say clearance side and the business logic, how that was done. Because I'm thinking that, okay, there could be a component with some copyleft license, but how it's used in application, for example, the usage could be okay. Like how this clearance was done, or was it done at your work?
Yeah, so we sort of we predefined sort of generally which licenses we'd be all right with using and not. And obviously you will come across more licenses that you haven't predefined because you can't go through every single license and determine whether you like it or not. And so those would be flagged up as sort of like an unknown one and require someone manually to decide. But we also didn't want to just generally across the whole system lock ourselves into deciding yes or no for every single repository. So, MIT, just the first one that came to my head, might be fine for one repository, but for another it might not. So I think we wanted to design it in a way that we could specify different permissions for different repositories. So we had a company level sort of um, like permissions sort of form in a way, and then um, the way the engine's code is sort of organizes then into organizations and then repositories. So there was this sort of hierarchy of permissions, so that if a repository had specific permissions, then that would overwrite the sort of the company ones. Sorry, I hope that made sense. But yeah, so it's sort of you can then define for each repository which one specifically you would want to use or not use as well. But you don't
Okay,
have to do it
so
for each
yeah,
repository.
because what I have seen in the past was that, for example, there can be, let's say, corner cases, maybe that, okay, this is strong copyleft component, but it's used that way and it runs in own thread and it's not directly accessed, etc., etc. Then the usage could be okay. So there's kind of exceptions that you could have deny list, that
Yeah.
this license is on deny list, but when used that way, it's okay. But I don't know if those are handled one by one, or were you able to do some sort of automation there as well? Because that could be interesting, because more and more open source is used, and I think more and more we will be seeing this sort of cases that, okay, this is, I don't know, strong copyleft, but when used that way in this environment, it's okay still.
Yeah, sort of, yeah, similar to I was saying before, is in like Engine want to be able to use Engine's own software. So that's sort of like a exception case that we wanted to be
Yeah.
able to define. So I think the way that we did it, we looked at the repository name or the organization name and flagged that as an organization that would be fine using. Um, so I guess you would have to do that bit manually, but then it would automatically flag up if you applied it to each repository or as a company-wide rule.
Yeah. And then, you do it once and, that's okay for next whatever release or round or however it was done, like CI/CD
Yeah,
round. Yeah.
yeah,
Perfect.
absolutely.
I saw some comments from Howard in the chat. We have some components that are released under AGPL, but it's essentially dual license. And that's why we needed to be able to say, we don't want to take a dependency on this external AGPL, but this is engine X component, which we publish as AGPL is okay for us to consume as we're the copyright holders. So the whole point is being able to apply business rules, what you need to be able to do to layer on the complexities. And the key guiding thing, the key point in the end is to figure out how to manage risk. Now, Stephen had a note that the IP maturity index is a really interesting concept, and it would be useful if it was adopted more widely across the industry. He asked, can we be told a little bit more about how that's calculated? Because the SBOM working group in OpenChain are looking at quality metrics. And Howard replied, just on firstly a note about automation, that if we can manage 80% of stuff automatically, that's great, because we have bandwidth now to focus on the 20% that needs human intervention or is nuanced. Going back to the IP maturity model, he notes that it's really useful for Engine because we want to encourage internal people to adopt open source components that Engine has created. And we need to be able to have an easy way for people to assess how mature the code is and whether they should take a bet on it.
This is really exciting. Howard has shared some links about this on GitHub. So there's the maturity matrix from Engine on GitHub, and then there's the rules and definitions. And these links are in the chat transcript. So what I'll try to do is extract those later and put them beside the recording of this call. I noticed that Stephen Pollard is saying many thanks for that. And Steve Kilbane is just noting that this stuff is really useful for inner source as well. Howard, it's fantastic that the IP maturity matrix and the rules and definitions are public and open source themselves. That is a really significant community contribution that we will echo and share with people in detail. That's really nice. Okay, we're, I think, at a really good point where we can say this is one of our most information dense and super practical webinars yet. So I'll be publishing the recording either the end of this week or the beginning of next week, and it will be promoted on our social media and so on. We'll be probably repeating it quite a few times in the next few months. We're going to be pushing on social media in August, September, and through to the Open Compliance Summit in the October in Japan. So hopefully, if you're listening to this recording sometime in the next 3 months, we managed to get it to you and you're someone new. And if you're one of our more regular community, I'm glad you're listening in as well. We would love for you to give feedback on the kind of process learning here, have a look at the maturity matrix, and perhaps contribute to our education work group with some of the learnings and inspiration from this call. Steve, Howard, Stephen all sending congratulations to Charlotte and also saying that Endjin has some nice blog posts on other topics. So head over to their website. It'll be linked on the page of this recording. And I'll just say, Charlotte, you're a really good presenter and the work you've done has been truly useful. I'm looking forward to having you back and seeing what you're doing next. So have a beautiful day, everyone. And thank you for being here. Oh, I nearly forgot to say, earthquake was fine, not heavy here, but I think Kagoshima and Miyazaki have got 4.6 and there's a tsunami warning, so they're having a rough day. Thank you all. Have a beautiful day. And thank you, Howard, as well, for ending and saying that we can ping you with any questions. Bye-bye, all.
Thank you. Bye.